Welcome back. This video is part of my series looking at the EOS R5 in gory detail. As I was putting this video together, I realized that there's way more to talk about with the autofocus system that will comfortably fit in a single video. So I've decided to break this video up into several parts, or break up the discussion on the autofocus system into several parts. In this part, my focus, pun intended, is going to be on some tests of the autofocus system, my subjective experience with the autofocus system, and some for still photography, and to compare that with my experience with my old 5D Mark IV DSLRs. Now, I had high expectations for the R5 due to my experience with dual pixel AF on my 5D Mark IV. I was very impressed with the Mark IV's ability to snap things into focus, regardless of which AF system I was using, but especially with the dual pixel AF. And I expected to see the same or better performance from the R5. So far, I have not been disappointed. Now, let's be honest about something up front. Properly and completely testing an autofocus system is not easy. Some reviewers will attempt something, they'll have some ad hoc tests that they're doing. They may test a few things in a highly uncontrolled manner, but I have yet to see any publication doing camera reviews that has done anything that's either comprehensive or well controlled when it comes to testing an autofocus system. Then again, the simple reality is that the autofocus system is possibly the most complex subsystem in a camera to test. It's not like measuring dynamic range or a lens's resolution. You can't just take a few images and be done with it. And even as you'll see later in this video, you can run into weird behaviors that don't show up in the real world. They're purely artifacts of your test setup. The problem really comes down to being that there's a large number of variables that have to be controlled for, and some of the most important ones are external to the camera itself. For example, how your test target's designed, or the lens that you're using for testing. And obviously testing all of these variables takes time and resources. And, you know, I can completely appreciate the problems that camera reviewers have in, weighing the cost-benefit analysis or cost-benefit ratio for doing this. Consider that Canon's engineers in an interview back when they started with dual pixel AF said that it took them 6 months just to test and validate that dual pixel AF worked properly with all of their existing line of EF lenses. And that was just basic testing. So what's interesting to me and why I think AF performance warrants more discussion than it gets is that we're kind of at a point in camera development where, thanks to changes in technology, things like autofocus performance and other ancillary features really do matter again. In many ways, it reminds me of the mid-90s. With a film camera, the film's performance wasn't material to the marketing or testing of the camera. You could put any film in any camera. So you didn't talk about image quality or dynamic range when reviewing a camera. It was the things like autofocus performance, the numbers of autofocus points, and things like that that made up the talking and testing points when reviewing a camera. Now, obviously, digital cameras changed a lot of that. We aren't all using the same film stocks anymore, and much more of that lays on the sensor. However, by 2007, if not much earlier, DSLRs pretty much could already do everything with sort of autofocus. They could track easily subjects closing at speeds in excess of 50 kilometers an hour, and they could do that when the thing was 8 meters away from the camera, which, I don't know about you, but I wouldn't want to be 8 meters away from something coming at me at 50 kilometers an hour. And, quite honestly, looking at the publications of, camera information from, like, say, the 1D Mark III to the 1D Mark IV, it's pretty apparent that the limitations at that point had less to do with the camera's ability to, read the sensor and more to do with the lenses and their motors and how much power they needed. However, with the move to mirrorless, this kind of information is also long gone from the marketing material. Yet that very change from DSLR to mirrorless has fundamentally changed the way camera autofocus systems work and, by extension, how they perform. The reality now, in so many ways, is that digital sensors are becoming more like film. That is largely interchangeable from a quality perspective. And I don't think many people want to admit that. But the thing is diminishing returns from increasing resolution and increasing technical parity between the companies that make digital cameras is pushing the differences in terms of features between cameras and brands down to being such a small factor, at least the sensor's performance, that it's not really that much of a compelling argument for choosing one over another. The other problem, of course, is that while camera makers don't provide detailed data about the performance of their autofocus systems, the problems and difficulty in testing them also means that there's no independent reviewers that we can turn to instead. At best, you can cobble together an idea of how things will perform based on, well, little more than uncontrolled ad hoc testing and anecdotes. Now, unfortunately, I'm not going to be able to change that here, as much as I'd like to. The reality is I don't have the time, the space, or the resources to put together anything approaching a comprehensive test rig and setup. And as the result of that, the best I can offer is to, add a few more anecdotes to the discussion with a little bit of quasi-scientific testing. With all that said, let's get to talking about the R5's autofocus performance in my experience. So, one of the limitations of Canon's dual pixel AF is that it's only sensitive to vertical contrast or vertical lines. And, that certainly seems like it should be or could be a problem in practice. After all, for years and years, camera manufacturers have emphasized the number of cross-type points in their DSLR AF systems. And of course, the advantage of those points is that they're sensitive to contrast in any orientation and basically therefore can, in theory at least, focus on anything. However, in practice, I've found the R5's lack of horizontal sensitivity just isn't a problem. In the real world, I've found it extremely difficult to find conditions that are so perfect as to actually cause the camera to have trouble focusing. And basically, in my experience, you need an extremely clean, extremely uniform surface that's both in color and lighting. That is then almost perfectly aligned so that you have your horizontal contrast is almost perfectly aligned to the horizontal axis of the camera. Even then, in testing, I've been floored at the camera locking onto things. And I think part of that comes down to the R5's resolution, the imaging sensor, is so high that it can lock on to minuscule surface markings or even like dust on the surface. And so a surface that would seem to be problematic, there is something there that it can find. And, I've run into situations where it will lock on to a horizontal line that I can't see any reason that it should be able to find contrast to lock onto. And it'll lock onto it, and I have no idea what it's seeing, but it's in focus. In fact, I generally can only create focusing problems artificially with extremely uniform and clean surfaces. So, for example, trying to focus on these horizontal blinds when they're perfectly aligned with the sensor and free of anything on the surface that could provide something for the camera to lock onto. Even then, in my testing, I ran into many situations where the sensor would reliably lock on to the blinds, and even as little as 5 or 6 degrees of off-axis rotation, and in some cases much less than that, would reliably get focus to work. Now, certainly a quad pixel AF system, which is rumored to be one of the technologies that could potentially show up in the rumored / anticipated EOS R1 sometime in 2021, would render this whole issue completely moot. But practically speaking, in the real world, I've yet to find a situation where the dual pixel autofocus system couldn't focus on something due to the horizontal nature of its contrasts, or vertical nature of its contrast sensitivity. The second thing that I wanted to look at more closely is how the R5 handles gross defocus situations. So when the lens is way out of focus. Gross defocus handling is at least moderately important when dealing with subject acquisition, as it's the difference between the camera snapping the subject into the focus using the lens's highest speed drives because it knows where it needs to drive the lens to, or using lower speed, slower hunting algorithms. Now, this is not something I've seen talked about either in reviewers or by Canon, and to be honest, I can't remember Canon talking about gross defocus capabilities since the EOS 1D Mark IVs back in 2009. So to test gross defocus performance, I disabled the lens drive when AF impossible option under the AF4 menu, and then I stuck the camera on my 100 to 400, set it to 400 millimeters, and pointed it at a test target just over 2 meters away. Focused at infinity and minimum focus distance, so I did this both ways, and I repeatedly alternated between making small focus adjustments towards proper focus manually and activating the autofocus system. Basically, the gross defocus distance limit, or capabilities, however you want to put it, is the point where the camera would actually take over and focus properly. So this is what the target looked like when it was out of focus and in focus. And the one thing that jumped out at me immediately in this test was this is another example of just how complex testing autofocus systems can be. So I had done some initial testing using a black and white sign on the wall at about 2 meters. And, before I even started sort of writing this or doing anything, because I just wanted to see what was going on. And of course, I needed to have some data for writing this actual review. And in that testing, I found the R5 and the 5D Mark IV both performed about equally. However, when I came back and went to shoot video for the test, I was at a slightly different distance. It was not quite the same setup. The angles were different, etc. And I saw completely different behaviors from both cameras. What I saw from the R5 was that it would attempt to focus and then stop without achieving focus. And in some cases, it even drove the lens in the completely wrong direction. So like back towards infinity when it should have been focusing closer. Now, if I re-enabled the hunting option, it wouldn't have a problem locking on at all. It would just snap there, basically. On the other hand, the 5D Mark IV showed a different behavior. It, instead of having a fairly limited range of being able to lock onto the target, it would lock onto the target like regardless of the initial focus position. So I could have it focused at infinity and it would snap the target into focus. Now, in my previous research on autofocus systems, I found that it's potentially possible to create a situation where you can trick an AF sensor into thinking it's focused when it's actually not. And what you needed for this was the right frequency of contrast lines that basically caused the sensor, and it had to be at the right distance and so on, that basically caused the sensor to think that the in-focus pattern that it was seeing was just soft or gradiated lines and not sharp lines. And I think this is what was happening with the two cameras. In the case of the R5, it was tricking it into thinking it was in focus, and then when it remeasured, it realized it wasn't, didn't know where to go, and due to the hunting option being disabled, it just stopped. For the 5D, conversely, because of the resolution of the sensor and so on and so forth, it was tricking it into thinking that it was closer focused to the sensor than it really was, and then when it remeasured, it would basically just spiral its way in, even though it wasn't hunting. Thinking that this might be the problem, I repeated the test with a completely different chart. It was a solid white sheet of acrylic with a single strip of black gaffer tape on it. So there'd only be one line there. And this time I was focused on the edge of the tape so that, I had a very defined high contrast line and not a repeating pattern of light and dark. In the second round of tests, which is the one that's included in this video, both the R5 and 5D Mark IV behaved virtually identically. And this was the same results that I had seen in my initial testing. So this is, like I said, this is one of those things in how complex testing can be, because you can create situations where the test actually messes up the test. So I do want to point out that I wouldn't draw too much in the way of conclusions from this one synthetic test. Way more testing would need to be done under way more conditions, different light levels, different subject distances, etc., to truly draw meaningful conclusions. Okay, so synthetic tests are nice and all, and I'm going to be doing some more of them going forward, but I want to talk about some of the practical stuff too. So servo tracking autofocus is easily the real challenge for any AF system. It's also where things get super complicated. It's also one of those areas that changes significantly from how DSLRs did or what DSLRs had for information to work with to what mirrorless cameras have. And obviously that means that performance parity is not guaranteed. So DSLRs had some advantage in this respect, as that their AF sensors and meters were extremely specialized for the purpose that they were designed to cover. Moreover, cameras like Canon's 5D Mark IV and 1DX Mark III have metering sensors that are not just sensitive to color, but also infrared light. So this gives the camera an additional way to see what the subject is and where it is in the frame. So for example, a bird in flight isn't going to have the same thermal or infrared signature as the clouds or trees that it's flying in front of. And so the camera can use that to more readily identify, hey, that's what I'm tracking. That said, there's obviously more than one way to skin a cat with this stuff. And with the advances in computing power available, mirrorless cameras can put that to use, along with using the imaging sensors much higher resolution. They can do way more sophisticated image analysis and use that for subject tracking instead of kind of the chunkier, simpler stuff that DSLRs were doing. So Canon's mirrorless cameras have a further advantage in that they can track, well, actually everybody's mirrorless cameras have the same advantage, but that they can track subjects over almost the entire frame. So you don't have to worry about it slipping out from under the autofocus pattern and the camera losing things. With the R5 here, you can use 100% of the frame, both vertically and horizontally, when it's doing the auto points or auto selection tracking mode. Compare that to the 5D Mark IV, which can only use the center 58% horizontally and 46% vertically. So with all that said, my experience with the R5's tracking AF is still limited. I've only shot some birds in flight for a few minutes and a few minutes worth of, few minutes shooting time, that is, worth of US Air Force jets performing at a local air show. Now, admittedly, as I'm going to show some of the footage or video, or some of the images from the air show, I want to prefix this by saying that due to the distance I was from the air show, I wasn't at Show Center. I didn't have, I didn't actually attend the event at the event. This was never for me about making great images of the planes. My objective was to get shutter time with the R5's AF system with a subject that I found historically challenging. So put briefly, my experience was that once the AF system locked on, it stayed locked on, and it did so far better than my 5Ds did. Uh, the challenge for me seemed to be getting locked on in the first place. Now, I think at least some of this, or a lot of this maybe, falls squarely on me. I'm definitely out of practice with this kind of fast-paced photography, and it's been a long time since I've shot an air show, especially one where I'm this far away. And of course, it's the first time that I've used the R5 for, well, this kind of photography at all. One final excuse I want to throw out in my defense, or in my list of excuses, is that how I go about shooting air shows. So my experience with shooting air shows is that it's best to pick up the plane and start tracking it as early as you possibly can, well before it gets to the actual maneuver that you expect to see it make that you're shooting. In this case, I was often, or when I was trying to pick up the plane, it often covered only about 5% of the viewfinder, if that. And I was shooting this with APS-C crop mode turned on with a 400mm lens. What I'm getting at here is that's a lot of shake, and it's very difficult to keep something very small kind of in the frame or where you want it in the frame. Now, while it has nothing to do with autofocus performance, this is one place where an EVF definitely has a huge advantage. So if I'd have been shooting with a DSLR that does crop mode, like say a Nikon D850, the viewfinder can't change magnification to keep up with the crop. And I'd be trying to keep everything inside a little box in the viewfinder that was otherwise just a full frame viewfinder. However, being mirrorless, the R5 in crop mode uses the whole EVF for the frame, so you get way better magnification. Canon specs the viewfinder on this is 0.76x magnification with a 50mm lens at infinity focus. If you do the math, in crop mode, the magnification should be like 1.22x, which, that's pretty handy. Okay, people obviously are no doubt argue about the effects of crop sensors and magnification and depth of field and whether you should do that or not, and da-da-da-da-da. Until they're blue in the face. What I have to say is that personally, having the extra magnification in the viewfinder made composing and tracking the jets that much easier, or at least I felt it did. And when a larger frame is just wasted space that needs to be cropped away anyway, the planes were never going to fill a full frame anyway. They were just too far away. There is something to be said about the advantages of doing it in the camera and having smaller files to work with instead of doing it in post. And crop mode on this camera with the nearly 18 megapixel image that you get out of it is definitely a feature I'm going to be considering using more in the future for those reasons. All right, so regardless of the start of the show or the start of the autofocus system, once I was locked on, the autofocus was incredibly solid. I shot roughly 1,000 images in one day, and it was not even that many passes, but that's 20 frames a second for you. And going through and looking at my images, I found about 15 total that were out of focus. So the first block of 5, I couldn't find any obvious mitigating factor to why they would be out of focus. It was the start of the burst, so it may have just been sloppy pickup from me or something like that. And of course, shooting at 20 frames a second, those 5 images amounted to 1/4 of a second of actual shooting. So in practice, in actually shooting the images, it was almost impossible to notice what was going on in the viewfinder, especially while you were taking into account tracking and all the other factors that you would have. The second block of images was another 10, and this is something I can't really fault the camera for. The jet I was tracking disappeared behind an intermittent row of trees, and at one point the camera shifted focus to a tree after the jet was out of, out from under or out of view. That's the right word I'm looking for. Was out of view for basically long enough that even though I had the AF system set to maintain tracking and reject intermittent objects, I could see how the camera would like lose the plane. It was just not in the field or in the frame for too long. So all that said, I'm not ready to draw any kind of conclusions about the R5's autofocus performance yet. I just haven't shot enough with it in enough circumstances. I haven't gotten to do a lot of wildlife with it yet, anything like that. But my early impressions are that it's pretty darn good. I'm really impressed with it. Tracking planes against the sky, especially when they're low contrast and not terribly big, I think makes for a challenging scenario. It certainly is challenging for me to keep the camera pointed at them. So that this may in some ways be kind of a worst case test. But I'm not entirely convinced on that one yet either. So if you're still here, I appreciate you sticking around to the end. I've only really just touched on the surface of the R5, and I've got a lot more videos coming talking about this camera, as I said, in gory detail and in depth. If you found this video useful or interesting, please hit that thumbs up button. Also, please consider subscribing. I've got more content coming, photography, video, videography, gear, going places when we can travel again, that kind of thing. So, consider, if that sounds interesting to you, please consider subscribing to the channel. As always, I want to say thank you for watching, and I will see you next time.